ACS check 114.
Loud and clear, roadblock 1.
ACS check 110, target 32, azimuth.
Loud and clear 2.
Check.
Flight station checks on channel 2,
One
please.
is out the gate.
Roger 1. RCV,
RCV go.
RDT,
RDT go.
TM,
2 is out the gate.
TM go.
Roger 2. Radar,
Radar go.
surveillances go, PI.
PI's on the way up the hill. Heavy's go call when he gets up there.
Copy that. LO,
Oh, okay.
PLC,
PLCs go.
ACS,
This
ACS
is
go.
a live broadcast from
Yes,
Poker
go.
Flat Research
MM.
Range.
MM
I'm
go.
Josh Hartman. I'm an undergraduate
CM
student at the University of Alaska Fairbanks studying biology, and I also work at the Geophysical Institute.
Howdy, I'm Joshua Nicely, a doctoral student and research assistant, also at the University of Alaska Fairbanks and the Geophysical Institute. I study volcanism on Venus. Tonight we are on day number 5 of the 2018 NASA Sounding Rocket Campaign, which runs through January 31st. This broadcast is funded through a cooperative agreement with NASA Goddard Space Flight Center and the NASA Space Science Education Consortium. Poker Flat Research Range is owned by the University of Alaska Fairbanks and operated under contract with NASA. This is the first time I will see a sounding rocket launch. Josh, can you tell me what we can expect tonight?
Well, you'll be able to hear countdown activity on the intercom system. We also have the countdown clock behind us, which will indicate where we are in the countdown. We may stop and hold as various pre-launch activities take place, and at the time of the launch, we'll track the rocket with the cameras on the range. This launch season, we have 2 missions. However, tonight we're only working on the diffuse X-rays from the local galaxy, or DXL, mission. The principal investigator for this mission is Max Galeazzi. We will now cut to the cameras watching the rocket.
Roadblock 1 is in position.
Roger 1. Kevin Abnett, 2106. Kevin, 2106.
I'm on the radio, Kathy.
Copy that, thanks. Are you outside?
ACS
Yeah,
check
I'm outside.
115.
I can see haystack and cannot see Cleary just yet.
Copy that.
ACS check 117.
Preliminary wind weighting launcher settings set at 83.6, azimuth 356.1, check 119.
RSO check 120.
Roadblock 2 is in position.
Roger 2, thanks. OC check 124.
Something to keep in mind while watching this stream is that there is a short delay between what is happening here on the range and what you're seeing on the video. To keep this delay to a minimum, you can refresh your browser. If you are in the Fairbanks area and want to try to see the rocket take off, you'll want to step outside and look to the northeast of Fairbanks toward Chattanooga when the count drops below T-3.
Visibility is currently poor. In order to ensure a safe launch, a visibility of at least 2 miles is required. Right now the cloud deck and snowfall is making it slightly less than that.
So we don't know if the rocket will be able to launch, but in hopes that it will, we've started the countdown, and it might happen very fast.
Dhaka, can you confirm that you switched the flow to P10?
Yes, it's confirmed.
EXP checks 109 and 111.
Roadblock at 32 mile. Can you turn your lights off for about 2 seconds? Okay, perfect. I gotcha. I can see the roadblock at 32 mile. Turn it back on.
RDT.
Power in the battery.
RDT, check step 123.
1.
RCV check 122. Now the DXL flush is started.
Thank you.
PLC check 125. TM check 126. PLC check 127.
Nine minutes.
TM check 129.
check 130.
PLC check 131.
TM check 132.
RCV check 128.
Eight minutes.
1,
The axial flush start.
2,
The
7 minutes.
axial power on. The axial hold shock.
1,
The axial exhaust 1 check flow solenoid.
2,
Exhaust 1 off.
Exhaust 2 check flow solenoid.
Jason Avila, please call 2106. Jason, 2106, please.
UXT power on, flush on.
Exhaust 2 off.
The axial cal on.
Cal off.
The axial cal off.
The axial complete.
The axial holds on. The axial power off.
1,
XP check 133.
2,
The axial flush started.
RSO check 134.
Hello has set final wind-weighted launcher settings. Elevation 83.6. Azimuth 355.4. Check 135.
RSO check 136.
Five minutes.
TM check 137.
2,
Kevin, can you report invisibility, please?
I can see Haystack, 32 Mile, and Cleary Summit, and I can see stars.
Copy that. Thank you.
We have visibility at this point.
UXT flush off, power off.
Axial flush start.
EXP check 138.
PLC check 139.
The axial power on.
3 minutes.
UXT power on. Enables on. Cal on.
2.
PLC check 139.
Cal off.
Enables off.
Enable.
UXT check 140, 141.
The axial holds off. The axial exhaust 1 check plus
142.
solenoid.
BS check 143.
PLC check 144.
Exhaust 2 check plus solenoid.
PLC check 145.
ACS check 146 and check 147.
TM check 148.
PLC check 149.
RCV check 150.
Exhaust 2 off.
The axial
TM
cal on.
check 151.
Radar check 152.
And PLC check
2 minutes.
153.
The axial cal
TM
off.
check 154.
The axial
RCV check
complete.
155.
The axial holds on.
ACS check 156.
UXT check 157.
TM check 158.
RCV, are you go?
Go.
RDT?
Go.
TM?
Go.
Radar.
Radar go.
Surveillance is go. PI?
Go.
Hello?
Hello, go.
PLC?
Go.
90 seconds. ACS?
Go.
VC? VS?
Go.
MM?
Go.
TM?
CM's go.
RSO?
RSS go.
The Rangers
Pressure
go.
off.
Keep the battery.
Is off.
UXT check
Pumping
160.
solenoid off.
UXT check 161.
Pump off.
2.
Check 162. UXT check
50.
163. UXT checks 164 and 165.
30 seconds.
The axial
Tin
power
for auto
off.
tracking.
UXT holds off.
TM 166.
Tin for launch mode enabled.
20 seconds.
ACS check 167.
10,
The axial holds
9,
off.
8, 7, 6,
Panel
5,
flush off.
4, 3, 2, 1, 0. Plus 1, 2, 3, 4, 5, 6,
RCV has auto track.
7, 8, 9, 10.
9 meter 2 has good track. 10 footer has good track.
Ignition.
Radar tracking.
Plus 20.
Tracking right of course on elevation.
Plus 30.
Meter auto tracking.
Plus 40.
10 footers auto tracking.
Slightly long, 1 sigma right.
Plus 50. Plus 1 minute.
D-spin.
Good D-spin.
Separation.
Nose tip deploy.
DXL on, UXT high voltage. Unlatch. DXL doors open. UXT doors open.
ACS on target. ACS starting first scan.
Plus 2 minutes.
Poker Flat staff is currently tracking the rocket as it ascends. You may have noticed they are counting up now. They're going to continue to do that until they lose track of it, as it has nearly completed its descent.
Now, explaining a little bit of the science behind this mission, you will hear an interview with Dr. Max Galeazzi.
I'm Dr. Massimiliano Galeazzi. I'm from the University of Miami in Coral Gables, Florida. I'm originally from Italy. I came to the United States about 20 years ago. I got my PhD from the University of Genoa in Italy, which is the city I was born. And then I moved here for my postdoc at the University of Wisconsin, spent a year at the NASA Goddard Space Flight Center, and then I moved to the University of Miami, where now I'm a professor in the physics department. Right now, we are in what is called the vehicle assembly building. So that is the first stage when we move here to the range. We ship all our instruments and all the other components of the payload. They are broken apart and they are shipped over here. They were tested at the NASA Wallops Flight Facility in Virginia. And once they're tested, they are boxed and shipped over here. Specifically, the purpose of what we study is look at what is called the diffuse X-ray emission. So if you look at the sky at night, what you see is a dark sky with bright point objects. Most of them may be stars, some of them may be, if you have a telescope, you see that are galaxies, a group of galaxies, or other complicated objects. If you look at the sky with an X-ray telescope, what you need to see that you have the same objects, but you also have a diffuse glow that permeates the whole sky. And essentially, the goal of our mission is to study some of the sources of that diffuse glow. So the rocket launch itself is about probably 10 minutes. The first couple of minutes are used to take us in space. Then we start doing our real observation. And we have about 5 minutes in outer space where we are observing the extrasolar object that we are observing. After that time, we close our door, we get ready for re-entry. So we impact the atmosphere, we come back. When we are back within the atmosphere, the parachute opens, and then the payload gently, or somewhat gently, lands back on Earth. If we start from the back, the big section, which is a 22-inch section that you see down there, is the DXL instrument. So this is our primary instrument, and this is the one that will give us the primary science. If you see, there are two big doors. So when we get in space, those two doors will open and will expose our instrument to the sky, and we can basically make the observation. Then we have the conical section, that goes from the 22 inches to the standard 17 inch, is telemetry. Basically, it controls all the electrical power in the payload, and it's also used to send the data to the ground in real time. This section here is UXT, which is the secondary instrument for flying. Again, you can see from the top that there are two doors. Right now, the two sections are not aligned. That's why those point sideways and this point up, but they will be co-aligned, and they will be observing the same part of the sky. The front part is more NASA engineering, has to do with the parachute is in the cone and other controls for the payload when we launch. And here we have our controls. So what you see here is what we will use when in the countdown. There are two things that I find very exciting about this mission. The first one is obviously the science. That's what I study, I know, and so this gives me the opportunity to know more about this object and increase, the knowledge that we have of the universe around us. The other thing is more on a personal nature. I really like to go on a rocket campaign because of the people I meet and the people I interact with. So far, for example, when I was at White Sands Missile Range, we work with NASA engineers, NASA personnel, the Navy supports us, the Army is there to support us. And here at Poker, the same thing. We have people from the University of Alaska, people from NASA, so people from quite different backgrounds that support us, and I find it very exciting to get to work with all these people, know their different background, and be able to work next to each other to get this mission going.
Can you repeat, please?
Launch danger area is clear.
Copy that. Thank you.
10-footer is LOS. TM getting drops. TM LOS.
9 minutes.
RCB LOS.
Plus 10 minutes.
Radar RSO, channel 4.
This is Radar.
Hey, can you throw the alphanumerics up on Radar B?
Sure. MM, CM.
Go ahead.
Got any thoughts from PI?
I haven't heard anything.
Is he still on the net?
Yeah, I'm still on the net.
I'm just wondering whether you're getting any good science, sir.
Definitely not as good as we were expecting. We got our counters that were close to 100% that time, and we don't know why. We are replaying the flight as we speak to see if we can understand a little bit better what happened. So we may be able to get some science out of it, but maybe not all the science that we were hoping for.
Roadblocks, come on back.
1 copies. 2 copies.
Tony, can you come to the blockhouse, please?
Roger that.
Project 36329, AGC calibrations for 9-meter 1 antenna system. Receiver set 1, link 15, frequency 2215.5 megahertz. Signal generator level at MDS is minus 65.5 dBm. Gas inject loss is 46 dB. RF off. MDS. Plus 5. Plus 10. Plus 15. Plus 20. 25. 30. 35. 40. 45. 50, 45, 40, 35, 30, 25, 20, 15, 10, 5, MDS, RF off. Project 36329, AGC calibrations for 9-meter 1 antenna system. Receiver set 2, link 79, frequency 2279.5 megahertz. Signal generator level at MDS is minus 66.4 dBm. Test inject loss is 46 dB. RF off. MDS. Plus 5. Plus 10. Plus 15.
The DXL payload has successfully touched down. Thanks for tuning in to our broadcast of the NASA-funded DXL mission. This live broadcast was funded through the NASA Space Science Education Consortium under a cooperative agreement with the University of Alaska Fairbanks.
Well, this is exciting. Still, one mission remains. For updates, check the Poker Flat Research Range Facebook page, follow @PokerFlatRR on Twitter, or subscribe to our SMS service by texting PFRR launches to 33222.
Two is in the gate.
Attention all personnel, there will be a post-flight briefing in the rack at 4:30.